Okay, now let's discuss the practice exam. It's focused on this, not focused. What? Okay. Practice exam. Okay, good. Let's see the first problem. Sine inverse of sine of 7 pi over 8. Well, let's see. First of all, sine inverse has a range from negative half 2 to positive half 2. So its value cannot be outside of it. So here, sine 7 pi over 8 is more or less this place. It's not in this range, so you have to find the corresponding point here between the range. This is a pi over 8. So sine x is sine pi minus x. So this is equal to sine inverse of a sine pi over 8. And when you have this number, this angle in the range, sine cancel with the sine, sine inverse cancel with the sine is a pi over 8. Okay, so that is this is the answer. Pi over 8 is the answer. You use sine x equal to sine pi minus x. And the cosine of x, important, cosine x, cosine pi minus x, they are not equal. They are not equal. Cosine x is negative cosine pi minus x. Okay, these two formulas are very important. Tangent of cosine theta, tangent of cosine inverse of a negative 1 over 3. Tangent of cosine inverse of a negative 1 over 3. So let theta be cosine inverse of negative 1 over 3. It is in 0 pi. We know that the cosine is negative in the second quadrant. So theta is between pi over 2 and pi, second quadrant. Second quadrant, sine theta is a positive. Sine theta is sine theta is positive. Okay, so we get a positive number. Now, and here cosine theta is negative 1 over 3 by the formula. Okay, now we are going to apply this stuff, the triangle 1, 3, theta, cosine adjacent over hypotenuse. So by the Pythagorean theorem, we got this opposite is a square root of 8. So this is a square root of 3 squared minus 1. 1 square root of 8. So that's a formula. And check here, in the second quadrant, tangent is also, tangent is negative. Here we need tangent, we don't need the sign. Tangent is negative. So after you determine the value square root of 8, tangent theta, it's negative, put negative sign here. Opposite over adjacent. So this is the tangent theta, and that's it. This is a tangent theta. So if you first determine the quadrant, after you get the quadrant, you just use the triangle to determine the missing side. Then you have tangent as opposite over adjacent. Okay, so that's the second problem. Third, Solve the trig equation 5 cosecant theta minus 3 is equal to 2. So you move 3 to the other side, it's a 5 cosecant theta is 3 plus 2 is a 5. Cosecant theta is equal to 1. Once again, we are not very familiar with the cosecant. We are familiar with its reciprocal. You flip two sides, you get the sine of theta is equal to 1. This is not the answer. It's the condition. We don't start from the original equation. We start from here. Sine. Let's check one period. With one period, only pi over 2 give you 1. So theta is going to be pi over 2 plus, this is 1 period, plus 2k pi for any integer. Okay, this is the solution. This is solution. It's special because here in one period there's only one solution. Sometimes there are two, but this part there's only one. Okay, this is problem 3. Problem 4. Verify the following equation as an identity. So to verify it, verify this secant of x, sine of x, tangent of x, secant of x squared. Okay, well, to verify it, you never start from the equality. So left hand side. Let's first copy it. Secant is 1 over cosine. Okay, secant of 1 over cosine, so 1. And sine times 1 over cosine, this is exactly the tangent. And times tangent x is tangent x squared. And then we know that the famous identity, 1 plus tangent of x squared is secant x squared is equal to right hand side. So we verify it. You see here, we start from left hand side. We simplify or manipulate the formulas and we get right hand side. We don't assume the equal to each other at the beginning. Okay, and that's it. Problem 5. Find the value. Sine, very long, sine cosine inverse 1/2 sine inverse 3/5. Okay, we're looking for this value. You will take some computation. Let's check. First, sine alpha plus beta, we have sum rule. Sum rule is a sine alpha cosine beta plus cosine alpha sine beta. So you have to know this formula first. In this formula, this is alpha, this is beta. So alpha is cosine inverse of 1/2. So cosine alpha is 1/2. Sine beta is 3/5. Okay? Cosine alpha, sine beta, they are both known. So this one is known, this one is known. So we need the sine alpha, cosine beta. This part, alpha is in the quadrant 1. Beta is also in quadrant 1. In quadrant 1. Okay? Then sine alpha is positive, cosine beta is positive, both in quadrant 1. The positive, right? So this place, let's check cosine. This is 1 alpha, this is 1, this is 2. Then by the Pythagorean theorem, you know the opposite is square root of 3. It's a 4 minus 1. Here, sine. Opposite is 3, hypotenuse is 5. So by the Pythagorean theorem, you can compute the other side is 4. So whenever you have a right triangle, you have 3, 4, 5. This is always the right triangle. Okay, so cosine is 1/2 sine is square root of 3 over 2. Here, sine is the 3 over 5. Cosine is 4 over 5. Okay, so you see you have this quantity, this value. You plug in here, and so you get the sine alpha plus beta. Be careful. So sine alpha, root 3 over 2, cosine beta, 4 over 5, plus cosine alpha, 1/2, sine beta, 3 over 5. Don't simplify it, just leave it like this. Don't simplify it again. Okay. Problem 6, verify. Verify cosecant is equal to this. Well, verify, remember again, verify, we cannot assume they equal to each other. We're going to simplify it or do something. Now let's check this part, this formula, the right hand side is more complex, so we start from right hand side. And right hand side, let's copy it. We have double angle formula. What is a double angle formula? Okay, so this is double angle formula for cosine. Because why we call it a double angle? Theta is twice of theta over 2, so that's a double angle. If you read from left to right, it's a half angle formula. But cosecant is related to sine, so we're going to select this one. So cosine theta is 1 minus 2 times sine theta over 2 squared. So it's 2 over 1 minus 2 sine theta over 2 squared. Okay, minus 1 cancelled. Minus is plus. So 2 cancelled. You get 1 over sine theta over 2 squared. Sine, 1 over sine is a cosecant, so it's cosecant theta over 2 squared. You see, you back to the left hand side. Right? So you're done about the verification. Okay. 7. We'll find the exact value of cosine 2 alpha, where the sine alpha with sine alpha equal to 8 over 17, alpha in the second quadrant. Technically, for this problem, we don't need the last condition, alpha in the second quadrant, because cosine 2 alpha is 1 minus 2 sine alpha square. It only depends on alpha, it does not depend on cosine. The other one. So it's 1 minus 2 times 8 over 17 squared. Well, let's compute. 8 squared 64, 17 squared 17. Okay, so it's 289. Well, yes, 289, and times 2, so 1 minus 100. 128, and this is 161. Okay, so cosine 2 alpha is equal to 161 over 289. Or if I do something wrong, computation wrong, just correct me. Problem 8. In the right triangle, we have the angle 20 degrees side B. Okay, so this is a pattern, or this is the rule. Whenever we write the right triangle, C is always 90 degrees. A and B are the acute angles. When you have angle A, the corresponding, the facing side is a little a. When you have angle B, the facing side is a little b. Okay, so this is the pattern, always is. In the exam, I will also show this picture. We will have different value, of course. Okay, so this angle is 20 degrees. We need to find AC and angle A. In this part, angle A plus B should be 90 degrees. So A is 90 minus B is 70 degrees. This is one answer. We need AC and angle A. Okay, another thing. Sine B is opposite over hypotenuse, so it's B over C. Yeah, we know B is 20 degrees. Little b is 5. Okay, this is a condition. Okay, so sine B is a sine 20 degrees. Little b is a 5 over C. So C is 5 divided by sine 20 degrees. You can also write like this. Well, we don't allow calculator, so we don't estimate. Do not estimate. Leave it like this. Leave it like this, okay? And then we have what A? Opposite over adjacent is tangent. So tangent B, so tangent 20 degrees is 5 over A. So A is 5 divided by tangent 20 degrees is 5 cotangent 20 degrees. Okay, so you see here 1, 2, and 3. Okay, that's problem 8. Okay, so problem 9. Problem 9 is the following. We have angle C very large, angle A is small, and angle B is unknown. It's 143.7 degrees. It's 10.3 degrees. This side is 48.3. Okay, so you can see that those numbers are not designed for the computation. They are designed for the computer. Okay, so problem 9 is about the sine law. What is the sine law? A over sine A is B over sine B is C over sine C. So this is the sine law. So first of all, A plus B plus C is 180. A is known, C is known, so the B is 180 minus the sum of them. Minus the sum of them. Let's check what is the sum. It's at 154 degrees. So it's 26 degrees. I assume I'm right. 36. Yeah, I believe I'm right. Okay. Okay, so you have this B. This is a 1. Solve the triangle means you are going to find 3 angles, 3 sides. So this is the missing angle, and you have 2 missing sides. Okay, so let's check. A over sine A is C over sine C. C is a 48.3. Sine C is sine 143.7. So A is equal to 48.3 times sine 10.3 degree over sine 143.7 degrees. Don't approximate. You are not allowed to use calculator. Okay, so that's A. And B over sine B over sine 26 degrees is 48.3 over sine 143.7 degrees. And then you move this sine to the right hand side, so B is 48.3 sine 26 degrees over sine 143.7 degrees. So this is the solution. Solve the triangle means find these three quantities. Okay, problem 10 is about the quotient rule. The quotient rule, b squared is a squared plus c squared minus 2ac times the cosine of b, the cosine law, Okay, so all the formulas are known, all the quantities are known. A is a 6.8 square, c is 2.4 square, minus 2 times 6.8 times 2.4 and times cosine what? Cosine 10.5 degrees. So what is a b? B is going to be all these terms. Don't compute. Again, don't compute. Square root. And that's it. Don't compute. Don't spend your time on this computation. Never compute 6.8 squared. It does not help. Okay, last one. Find the sixth term from this recursive formula. The recursive formula is an minus 1 squared minus 3 and a1 equal to 2. Okay, then nothing you can do. Just do it step by step. So you have a1. Let's check a2. a2 is a1 squared minus 3. So it's 4 minus 3 is 1. a3 is a2 squared. So a2 depends on a1. a3 depends on a2. So it's a2 squared. a4 is a3 squared. So you get 4 minus 3 is 1. a5 is 1 squared, so 1 squared minus 3 is negative 2. a6 is negative 2 squared is 4 minus 3 is 1. So this is a6, and that's it. There's no trick. Just ask you to follow the formula. Don't make mistake. Okay, so this is a discussion of a practice exam. I will put the videos about the mathematical induction and the sine law, cosine law, triangles quickly, not today, possibly tomorrow. Okay, thank you. You have questions, send me email. Let me show you all the pages in order again. So this is the first page of discussion. Second page, so I don't need to send you by email to get the more trash email. Third page, page 4, page 5, and the last page, page 6. Okay, very good. Thank you very much. We'll stop.